So in this video, we're asked to sketch the curve described by r, which is equal to 1 plus 2t, comma 2 minus t, when the parameter t is variant between -2 and +2. So essentially what this is telling us is that we've got the vector equation, since r is bolded, it's a vector, it's got an x and a y component. So the first one here is going to be what describes x, and the second bit here is what describes y. And it's a parametric equation because we have this third parameter, t, which feeds into both the x and y components. And what happens is as we change t, and we're going to look over this domain here, we should be able to figure out what the corresponding x and y components are, and then plot them onto a Cartesian plane. So I'm going to start by filling out this table I've made, where I'm going to list out different values of t, and then figure out what the corresponding x and y are. So we're looking between -2 and +2, so we just need to pick a few values in that range to work out. I'm going to go up in jumps of 1, but you could pick something else as well. So yeah, we're going to get it for 5 points here. Alright, so we said that x was equal to this equation here of the 1 plus 2t, and y was at the second part, so the 2 minus t. So if we substitute t as -2 in here, we're going to get 2 times -2, which is -4, plus 1, which goes to -3. If we sub it in here, we're going to get 2 double -2, so that's going to go to +4. If we sub in -1, all right, 1 plus 2 times -1 is going to go to -1. And then subbing over here, 2 double -1, that's going to go to +3. If we keep this up, the next one here, it goes to 1 and 2. The next one goes to 3 and 1. And the last one goes to 5 and 0. Alright, so now comes the sketching part. So I've got my x and y coordinate system set up. And I might just make a few marks to make it easier in plotting this a little bit to scale. So my x values here are going from -3 to +5. So if I make a few dents there, it's about right. And my y values are going from 0 to 4. Alright, so let's have a go at plotting now. So for this first one, t is -2, means that we pass through the point -3, 4. So that's going to be -3, 4, somewhere up here. So you can think about this point up here representing the vector, okay, when we have t is equal to -2. So if we look at the next point that we've got, t is equal to -1, it has to go through the point -1, 3. So that's probably going to be, let's say here, okay, -1, 3. And again, you can think of it as being the vector when t is equal to -1. So if we look at the next one, we've got the point 1, 2. So 1 is here, 2 is probably, say, here. Again, we can draw ourselves a little vector. So that's when t is equal to 0. We've got 2 left. So t is 1 when x is 3, so that's out here. Y is 1. And I'll pop this in a different color. Oh, didn't select it properly. So that's t is 1. And our last one, we've got 5, 0. So that's going to be all the way out here. T equals 2. Alright, so we were asked to sketch the curve described by this vector. So we've only considered at 5 points, but we know that there's obviously the capacity to calculate what's happening in the middle here. So we can kind of infer though, just by drawing, joining the dots as to where that line is going to go. And to me, it looks like this is just going to be a straight line that goes all the way down. So let's give this a go. Join all these dots. Okay, just becomes a straight line. So that there is the curve. R is equal to 1 plus 2t, comma 2 minus t within this domain that we've specified. So that's our vector equation or vector sketch of R. So that's pretty much all there is in terms of this video.